to see you so soon. So this is the next one, right? That we're just going straight into the next example here, where we're looking at shifting our parabola. And let's think about what this does. Now let's graph a new parabola. So this will be example 2. Let's graph a new one. And we'll go a bit quicker this time, but now we'll do y equals f of x equals x squared plus 2. So we're going to take our parabola and we're going to add 2 to all the values, right? So we're going to take our parabola, add 2 to every value. Let's see what happens. And we'll make x, and then we'll make x squared, and then we'll do x squared plus 2. And let's just see what the change is. And we'll see that maybe we don't affect the change that much, and then we'll do we'll do the change in f of x, and then we'll do the ordered pair, and then we'll graph it. So we're just going to do the same values. Let's just start at -3. And this will just center itself on the vertex. We'll talk about when we need to change our values. This doesn't change from before, right? This is the same function, x squared. We'll look at that change component after. This is 4, this is 9. Now I take every value I had before and add 2. So 9 plus 2 is 11, 4 plus 2 is 6, 1 plus 2 is 3, 0 plus 2 is 2, 1 plus 2 is 3, 4 plus 2 is 6, and 9 plus 2 is 11. And notice that we still have our symmetry back. The change though, right, the change for everything is 2, but from the last point, 11 minus 6, well, that's 5. 6 minus 3, that's 3. 3 minus 2, that's 1. And then this is 0, no change there. And then 3 minus 2 again is 1. 6 minus 3 is 3. And 11 minus 6 is 5. We can see that it's that odd numbered pattern again. So that growth pattern didn't change here, but what did change is everything moved up to y values, right? So everything moved up to y values. And we're going to see exactly how that changed. So let's look at our ordered pairs. So now I have -3 and 11. Now I have -2 and 6. Now I have -1 and 3. Now I have 0 and 2. Now I have 1 and 3. Now I have 2 and 6. And now I have 3 and 11. So let's make a nice big grid this time. Let's put it off to the side and graph this very nicely here. So I'm just going to make a nice big grid there. And we just only need to be concerned about the positive y values, right? We can see that our lowest y value that we got from our table of values is 2. This is our x. This is our y. Let's fit everything in. Our first point here is 0, 2. So there's 0, 2, right? X value 0, y value 2. X value 1, y value 3. X value -1, y value 3. X value 2, y value 6, 1, 2, 3, right up here. And by symmetry, I have it right up here. And then the next one is 1, 2, 3, 4, 5. This is 3, 11. And this is -3 and 11. So let's just show it 0, 2. This is 1, 3. This is 2, 6. And that is 3, 11. And by contrast here, this is -1, 3. Or by symmetry, not by contrast. What am I doing? -2 and 6. And this is -3 and 11. And actually, let's put it to the side because I don't want it to go. Oh man, what am I doing? These have to go off to the side because I don't want it to go through the parabola. So that's -1 and 3. This is going to be -2 and 6. Don't want it to go through. And this is -3 and 11. And now I can just make my parabola. I just go down and kind of make some lines as I'm coming along. Make sure I make some nice shallow lines as I'm going around the corner. Please excuse this phone call for just a moment. All right, sorry for that interruption. Let's take a further look at what we're doing here. Okay. So, let's get that going. There we go. So we were graphing this, putting it together. And we just have a quadratic that we've moved up 2 spaces, right? This parabola here, same parabola, moved up 2 spaces. So we can make a generalization about that k value, and we're just going to see that that k value takes our parabolas and just moves them up and down, right? That k value is just going to take our parabolas, move it up and down, and change how we look at that there. Okay, so we'll look at that in one more example. So example 3. And we'll see, we've seen it move up. Let's try and see it move down. And that would be subtraction. So this is x squared minus 4. Making our chart, we have x. So let's make our chart here. Let's get some values. This will be y equals f of x. And I'm just going to go straight into it. We know what the ordered pair is. We'll start at -3 again, right? And we just kind of fill in the gaps as we go along. So this would be -3 squared minus 4. That's 9 minus 4, that's 5. -2 squared minus 4, that's 4 minus 4. So that's 0. -1 squared is 1. 1 minus 4 is -3. 0 squared minus 4 is -4. And then 1 squared minus 4 is -3 again. 2 squared minus 4 is 4 minus 4. That's 0 again. And then 3 squared minus 4 is 5. And we can still see that that pattern still holds, right? This is a change of 1, change of 3, change of 5. And that pattern will hold for parabolas for the most part. But we'll see in the next example, before we wrap this one up, that the pattern can change, but it changes by a factor. The idea of the pattern doesn't change, but it can change by a given factor. So setting up a graph here, this is x, this is y. And let's take our points. So we have one at 0, 4 right here. Good. We have one at 1 and -3, and -1 and -3. We have one at 2, 0, and -2, 0. And we see some x-intercepts show up here. We have one at 3 and 5. And one at 3 and 5. Good. And we just connect our points, and we have a nice parabola over here that we can get some nice information from, just like that. Perfect. We have a parabola, got all our key points here. So we have a x-intercept. So we have some x-intercepts. Let's take a look at the key information about this parabola here. So the vertex for it is at 0, -4. The axis of symmetry, that's at x equals 0, right? That's our line where it's reflected. That always happens on the x coordinate of the vertex. A vertical line, it has the form of the equation x equals. X-intercepts in this case we can also get by algebraically. So if I take y equals x squared minus 4, well, x-intercepts always happen when y is 0, right? They always happen on the x-axis, and that's when y is 0. So we set y to 0 and solve. So this is 0 equals x squared minus 4. Add 4, and then we'll get 4 is equal to x squared. Let's take some roots. We'll take that root, we'll take this root, and we'll get plus or minus 2 is equal to x. So where we get our two x-intercepts as 2 and 0, and -2 and 0. So it's just from solving a equation like that we'll get our solutions. All right. When we're looking at domain, this is never going to change for a quadratic specifically. So the domain is always going to be all values of x. So I can choose any number, right? X is numbers that I can choose. And I can choose any number to put into a parabola here, right? So I can choose any number to put into a parabola. And then range, when I'm thinking of range, the range that I'm thinking of here has, well, the lowest value is -4, and then it keeps increasing forever. So that's either -4 to infinity, or this is, you could also say y is greater than or equal to -4. And then lastly, our y-intercept, we should consider that y-intercept as well too. That y-intercept, y-int, happens at 0, -4. And we always know that our vertex happens at the happens at this corner here, and we know that this corner specifically, is 0 and -4. Good. Let's meet you in the next part for lesson 1.